Here we need to again use partial fraction decomposition, and when we break up 3s minus 5 over s minus 1 squared, because this factor in the denominator is raised to the second power, when we break this up, we're going to break it up into the sum of two fractions. One fraction will have a denominator of s minus 1, and the other fraction has a denominator of s minus 1 squared. And our coefficients, or the numerators, will be constant terms. So here to solve for a and b, we want to multiply by the common denominator, which is s minus 1 squared, and that's going to leave me with 3s minus 5 is equal to, on the right side, here one of the s minus 1's cancel, so I get a times s minus 1, and then on my b term, both of the s minus 1's cancel. I can simplify the right side to give me as minus a plus b, and here's my constant term, and then here's my s term. So equating the coefficients, when I compare the s coefficients, I get 3 is equal to a, and then for my constant terms, I get negative 5 is equal to negative a plus b. Well, a is 3, so I get negative 5 is equal to negative 3 plus b. Add 3 to both sides, and we get negative 2 is equal to b. Okay, now to apply the inverse Laplace here, the inverse Laplace of f of s is going to give me y of t. And then I want the inverse Laplace of 3s minus 5 over s minus 1 squared, which can be broken up into, let's see, a is 3 over s minus 1. I'm going to bring my 3 out, so I have 1 over s minus 1, plus the inverse Laplace of b over s minus 1 squared, where b is negative 2, and that negative 2 can come out, and I get 1 over s minus 1 squared inside the inverse Laplace. So this first inverse transform is just my exponential function, where a is 1, so that's going to give me e to the 1t, or just e to the t, plus a negative 2 will give me a minus 2. On the second inverse transform, 1 over s minus 1 squared isn't one of my basic formulas, and so I need to apply a formula. We're going to talk about this a little bit later on, but this is the formula that I'm going to apply, where a is 1, so f of s minus a is this minus a would give me an exponential with that same value of a. So it's going to give me the exponential e to the 1t. Here a is 1. And in this case, f of s, in this case, that f of s is referring to 1 over s squared. And we know that if we have 1 over s squared, the Laplace of t gives you 1 over s squared. So that's this part right here. F of t would be t times t. And this is our solution.